Good morning, guys. Welcome to a gray and drizzly Wednesday. Today's lesson is going to include a little bit of, let's say, concern. The numbers I see of views on the videos don't quite measure up with the number of students in my classes. So it might mean perhaps you're not watching the videos, which would be a shame. Number one, I'm not doing this because it's fun, but number two, this is the only way you're getting instruction. So I would hope that we watch the videos thoroughly. I'm showing you what to do. That being said, I did get all of the material you sent me, the 3 prompts from yesterday, as well as the riddle worksheet. Obviously, you can Google the answer to the riddle. It's not the riddle I'm looking for, it's the work that supports the riddle's solutions. So in the future, please give me work, not just the riddle's answer. But the 3 prompts, I saw you guys doing work, but I saw a lot of mistakes. So let's go over how to do them right. And again, if you watch the videos, you'll see how to do them right. Okay? So number one gave you a system y equals 1/2 x plus 3 and y equals x plus 1. It was pretty straightforward. It was in slope-intercept form. There shouldn't have been any significant problem in the setup. I said in my first example that when they're both in slope-intercept form, you can simply set them equal to each other. And a lot of you guys did have that, no problem. The issue comes from when you are subtracting the x. Most of you did this, minus x, but way too many of you thought that that's going to cancel out to nothing. Since when does a half minus a whole equal nothing? It never does. That's wrong. A half x minus x is negative a half x. Plus 3 equals, this one drops out to nothing, so it equals 1. All right? So the variable would not have gone away there. We're going to subtract 3 from both sides and get negative 1/2 x equals negative 2. If I want to clear a negative fraction coefficient, I'm going to multiply by negative 2. That will cancel the denominator. It'll clear the fraction. It'll also make it positive because a negative times a negative is a positive. And when you distribute to the other side, you get x equals 4. Now again, we're not finished. X equals 4 is half of the answer. I'm looking for the coordinate where the lines cross. I got a number, so I know they're going to cross. So let's plug it in and finish the problem. Either of these 2 equations are good. This one's nice and easy. It says y equals x plus 1, right? Plug in the 4, because you just told me that x was 4. And you get a solution of y equals 5. That's the coordinate where they cross of 4, 5. Okay? There is one solution. We just found it. It's the coordinate 4, 5. Don't just tell me the answer is there's one solution. That's not what we're looking for here. We're looking for the place where they cross. All right? Everyone see it? Take a look at it. Make sure that you can do this. This is actually the easiest form to do this problem in. So if you're canceling out the x's here, thinking that a half x minus a whole x is nothing, you got a real concern. I'm worried about whether you understand the concept. Please be careful. Moving on to number 2. Number 2 gave you one equation in slope-intercept and one that was not. Okay, there's a number of ways to go about this problem, and they're all fine. You could plug this in to the y. There's nothing wrong with that. You could put this equation in slope-intercept and set them equal to each other. There's nothing wrong with that. They're both fine, so it's really whatever you want to do, but you have to do it carefully. I'll use the substitution method. I'm going to take this stuff and I'm going to plug it in to y. So I get negative 6x plus 2 times 3x minus 2 equals negative 4. Again, this is one approach. It's perfectly fine. You could also instead have turned that second equation into slope-intercept form and solved it. It's okay. This works though. I'm going to distribute that too. Negative 6x plus 6x minus 4 equals negative 4. Negative 6x plus 6x is nothing. And what I'm left with is negative 4 equals negative 4. Well, the variable dropped out, and I'm left with a true statement. Because it's true, and there's no more variable, I can't go any further. But the fact that it's true tells me that this one has infinite solutions. Because it's the same line. Okay? No matter how you went about solving it, if you did it correctly, you're still going to get the variables to drop out, and you're going to get a true statement left over. What that tells you, again, is that they were the same line, and therefore there are infinite solutions. And the third prompt. Gave you x equals y plus 2 and y equals x minus 7. Again, there's more than one way to proceed. You can either plug in this for x, you could plug in that for y, you could put them both in slope-intercept and set them equal to each other. It doesn't matter. It'll all work. Here's what I'm going to do. I'm going to take this information that is what x equals, and I'm going to just plug it in to that x. So I have y equals y plus 2 minus 7. All right, well, I'm going to just do the constants first. What's positive 2 minus 7? It's negative 5. If I subtract y from both sides, I get 0 equals negative 5. Now again, no matter what approach you took just now, you should find a statement in which the variable drops out, but the statement's false. 0 obviously does not equal negative 5. What does it tell you when it's a false statement with no variable? It tells you that there is no solution because these are parallel lines. Okay? Please understand, when there is a solution, a single point where they cross, you find that solution. If you find that the two lines were the same exact line, what it tells you is that there are infinite solutions, and you say that. If you find that the lines were parallel, you say that there is no solution because they don't cross. You say that. That's how you solve these problems. Please practice. My advice is that you actually watch the videos, again, watch the videos from Friday and from Monday. You could watch yesterday's video if you want, but it was just advice and the problems. It wasn't problems being solved. I'm not going to give you any additional homework for tonight. I am going to suggest that you do pay attention to what has to get done, though, on a daily basis. The IXL assignments were due. They're not being accepted late. The riddle worksheet and the 3 prompts from yesterday were due. They're not being accepted late. So you have to be on top of your work. There's nothing else we can do. All right? We may come back to school in May. We may not come back to school this year. So we have to keep on top of this if we want to learn anything and move forward. All right? As time progresses, we'll also start talking about course selection for next year because that was supposed to happen around now also. We'll work it out. Let me know if you have any questions or problems. I have been receiving everything you've been sending me. You don't have to ask. Make sure when you do your attendance, you see that you've clicked the submit button and it pops up with the window that tells you it's been submitted. I attached a little document last night to help to clear that up, because some of you said that you did your attendance, but it never showed up. Any questions, let me know. Otherwise, have a nice day.